In this video, we'll take up the homework questions on the logarithmic scales. So the first question, they're asking us to determine the pH to 1 decimal place. So you can use the formula pH equals negative log of the hydronium ion concentration. So yeah, not much to that. For number 2, calculate the hydronium ion concentration. So once again, you can use the formula. So it's 10 to the power of negative 2.2 for 2a. Just punch in your calculator. For number 3, how many times as intense is an earthquake with a magnitude of 7.2 than an earthquake of 5.6? So you take 7.2 and subtract by 5.6 to see the difference on the Richter scale between the two earthquakes. So 7.2 subtract by 5.6 is 1.6. So if it's 1 unit change, it's 10 times as intense as before. But since it's 1.6, we're working with a number between 10 and 100. So 10 to the power of 1.6. So 39, let's say about 40 times as intense. So this is based on your understanding of the Richter scale. If you didn't know that a change of 1 unit on the Richter scale is a 10-fold increase in intensity, then you won't be able to generate this relationship that I've written down here. Okay, number 4, if it's 390 times as intense as the earthquake that measures 4.2, so you just take 4.2 plus log 390. Okay, number 6. So number 5. The 5 gave us a nice fact. It says that if it's as a decibel is 0, it measures the intensity of the sound is 1 times 10 to the negative 12, which is a threshold of here, 1 times 10 to the negative 12 watts per meter squared. So everything is relative to the threshold of sound, which is 0 decibels. So if it's a normal conversation, calculate the power per unit area carried by the sound. So basically, you're just rearranging the formula, but you let I sub 2 be 10 to the negative 12, because now we're working with the normal conversation and comparing it with the threshold of sound. So same with 5a and 5e is basically the same. Let's see. 6 we're working with the energy released from an earthquake. So they gave us a new formula, but basically the way this scale works is that if you change 1 unit on the Richter scale, it's 31 times, the energy release scale, it's 31 times the amount of energy released. Okay, so it's a strange number, but that's what it is. So change of 1 unit, it's 31 times the amount of released as before. And I can tell because I saw the base of the logarithm. So using that fact, you can just answer B and C. But A is the most interesting question, 6A, because it's a new scale, something we didn't talk about. And there are many logarithmic scales that we haven't talked about, but basically it's up to your interpretation of how you design the scale. So in this case, 1 unit is 31 times as much as the energy released beforehand. Okay, so an extra practice for number 1, we're comparing with 2 earthquakes again. So once again, let's see. Oh, it's 1 earthquake measures 6.7 on the Richter scale. How many times as intense as a 0 earthquake? So just solve for the ratio. For B, you're comparing 2 earthquakes. One is 1.1, one is 6.7 on the Richter scale. So you're actually, not nearly as intense as before. So you're finding what is the intensity of the earthquake that measures lower on the Richter scale. Because usually it's the other way around. But just read the question carefully. Number 2 is exactly the same as number 4 from above. That was just a typo, I think. Number 3, so you have 2 earthquakes. Wow, one is 8.3. That is huge. 8.3 on the Richter scale, and one is 4.8. Find the difference, and basically it's now 3,162 times as intense as before. Number 4, I basically found the difference in the two sounds on the decibel scale. But be careful, because the way the decibel scale works, I have to take that difference and divide by 10, because each 10 unit change represents a 10-fold increase, or 10 times as intense as before. So, yep, once you sub that in, it's 3,981. And number 5, you need to know the intensity of the threshold of sound, which is 1 times 10 to the negative 12. If you didn't have that fact, you wouldn't be able to do this question. So, anyways, using that fact, I can generate the ratio of my voice to the to the threshold of sound, and then I just do 10 log of that ratio, so about 49.5 decibels. Okay, so that's homework solutions for logarithmic scales.